All right. Good afternoon, everyone. I'm extremely thrilled to be here. My name is Ishan Shams. I'm a PhD student at George Mason University, and today I'll be talking about our project, Planetary Mitigation Gateway. We've got Myra Bembakis right over there. She's been managing the project, and she's also the project manager for the NASA NNSA Neo Mitigation Project. We've got Dr. Fulian over there who is supervising us, and he is the director of STC. We've got some other team members who have been with us supporting from the day one from NASA NNSA Joint New Mitigation Team. We've got Joseph, Brent, Luke, Ronald, and Rutan. We've got Bernie, Kevin, Kathy, and Megan as well. We've got new team members collaborating starting from this year. We've got Dr. Groves Bauer and Dr. Jesse Dodson who are going to be helping us with the NEO data connection piece. Let's spend a couple of minutes talking about the challenge, purpose, and the impact of this project. Now, the NASA PCO directs critical studies, and we've got NASA NEO survey that provides scientific data to necessary data to basically provide and help to mitigation. Sorry, I forgot. Mitigation decision-making planning process. Now, what happens is that in order to get those data, we have to go through numerous organizations and researchers to get what we actually want. Now, the problem that arises over here is the lack of organizational cohesion in this industry. This is where we come in because data dispersion is a major concern, especially when time is a critical factor. So what we do is we came up with an architecture to build a one-stop shop for PD domain-specific data, information, and knowledge by the mitigation team for the community. Now, we have came up with a modern architectural design principles to build an advanced PD knowledge base, smart discovery, file archival technology, and a 4D, which is soon going to be a 5D visualization tool for mitigation. We believe that this will actually have a huge impact in the community in the near future, starting with the maximization of linkage of scattered data from various organizations and sources. We're also hoping that it will actually increase the collaboration and engage the PD community to analyze and study risk from potentially hazardous objects. Now, 5 years from now, some of us will be here and some will either graduate or retire. So all of our assets, all of the research that we have done might actually vanish. But with this application, we'll have everything intact under one roof as a one-stop shop service. And basically, when the next generation comes in, they can actually start from where we left off. To reiterate, we basically came up with a modern architectural design principle. So no matter how complex in nature our backend process works, we want our users to experience and have the best experience with our application, with with a really good user-friendly experience. So we came up with four tiered application stack. Starting from the very bottom tier, we have our own domain crawler that basically fetches the latest PD-related contents from authoritative sources such as NASA, NNSA, ESA, JAXA. And we also have our own PD-related services, PD-related researches and publications that we all compile together and we move it up to our second bottom tier, the knowledge base. In the knowledge base, we train our domain ontology with all of the gathered information, and we also apply another algorithm to basically get rid of all of the data that are not relevant to PD at all. This knowledge base becomes our driving force to support the reasoning engine and the PD processing workbench. Now, the reasoning engine provides services such as ranking and recommendation to support smart search, and the PD processing workbench basically allows us to provide a better visual analytics. Now, no matter how complex the architecture looks over here, in the end, this is what the user gets to see. A very simple user interface, very user-friendly, providing 4 different components: Smart Search, File Depot, Glossary, and Visual Analytics tool. Now, before I do this video demonstration, I'd like to take a little couple of seconds to thank the mitigation team. I've actually learned a lot from brilliant minds, and most of above all, I've actually had a lot of fun. Now, one key component that I was able to learn from this new mitigation team was the concept of having a little bit of open-mindedness. So when we try to learn something, it's very important to have an open mind. So today, in this demonstration, I will be showing a couple of use cases, but as you see this presentation, you'll also think of a couple of use cases that this application is useful for. So to start off with, it's very simple. Our goal is very simple. We want to be a one-stop shop for all PD-related data contents, and someday one of the decision-making tools when time comes. Very good example is the glossary page. We have over 150 concepts. If you're fresh or if you want to get a touch up on like the industry keywords, you can just quickly come over here and then look at some of the components and then understand the concepts. These concepts have been also reviewed by the new mitigation team, so like the verification of this is 100%. These are also supporting our reasoning engine, which basically feeds our smart search engine. Now, our smart search engine is starting with 67P, shows that it's actually very scalable. So whenever you search for something, it usually would come up with the result of your answer within the first 2 or 3 options. So in the previous page, you saw that we searched for 67P. Although it's very small and little, it was actually able to show what you're talking about, the Rosetta comment. Another use case we went for is venue. Now, what we do is injected the reasoning engine, and we provided the reasoning engine with a mechanism to promote authoritative sources, give values to them. So sources like NASA, ESA, JAXA will have a higher weight compared to a regular website. And that's what you see over here. I searched up venue, and then the NASA visualization for venue. Another very cool component that I want to show you over here in the Smart Search is basically PDC 2019 exercise. So a very cool thing that we were able to do over here was that an integration with our visualization and our Smart Search. So in our visualization tool, if we have an asteroid or a comet, then it will also show when you search up in the Smart Search. So PDC 2019 was actually injected in our visualization tool. So for this demo purpose. So a special shout out to Brent, Josh, and Bruno. They were able to, in a very short time, they were able to give their spacecraft mission data. So we were actually able to show it in our visualization analytics tool. I want to basically explain how vast this whole program is. To start off with, you would notice that the spacecraft, venue, and then we've got Sun, we've got the PDC 2019 as well. We can actually include a lot of use cases. We started with PDC 2019. The data set started from 2020, and then it ends at 2027. You will notice that the Earth is orbiting around the solar system, and we've also got PDC 2019. You will also notice that the spacecraft starts over here. And then by the time it hits 2024, it actually tries to catch the PDC 2019 to be in synchronized with that asteroid. You would very soon notice that the asteroid of PDC 29 changes, and that's exactly where the spacecraft deployed the nuclear to let the PDC 2019 have a deflected orbital path. That way we got saved, apparently, hypothetically. More use cases of this visualization tool can be a user with their own data set, their own calculations. They can just quickly come in, they can just put the data over here, and then they actually get to see the results in real time in 3D. Another use case of this project, say for an example, if you want to look at a shape model of, for an example, an asteroid. There are a lot of pictures out there, but if you want to see a 3D model, you would actually have to download a specific advanced software. Over here, we actually work with sources like Horizons, Ames, ESA to actually get these kind of data sets. So all you really have to do is just search it up over here, and then you get to see the 3D model and basically navigate around. 67p, another great example. We worked with Dr. Gerbs-Bauer and ESA to basically get this. And you can see how quickly it rendered in 60 frames per second. And we really didn't have to go through any lag time to have this up and running. With that being said, a lot of new additional use cases can be added to this visualization tool, and it just needs a little bit of push. We have made a lot of great progress so far, and we hope that you can actually see that as well. We are not done yet, and we are trying to make this product even better. So to start that off, we are going with this couple of future enhancements. Starting off with the collaborative connections to more community data sources, such as small bodies, comets, horizons, PDS, etc. PDC 2019 was a wonderful pilot use case. We are actually trying to incorporate more to show the vastness of our visual analytics tool. Our web crawlers, search performance, PD knowledge base, and reasoning engine are also going to be enhanced so that our users get to experience a better smart search. As a continual process, we have been working towards this. Our domain experts will be testing, evaluating, and helping to improve the system constantly so that it goes through that agile, iterative enhancement process. Also, additionally towards that, we are also trying to engineer this gateway as an operational service so that in the later future, it can be a little bit more customizable. Coming to a conclusion, I would like to thank PDCO for sponsoring, funding this project. Without them, it wouldn't have been possible. We'd also like to thank Ames for providing their backbone, Smart Search, so that we could have incorporated something similar to it in our mitigation gateway. NASA, Goddard, and CCS have been helping us with the computing facilities and all of the visualization tool, data integration, and gateway experiences that you guys have noticed has been inspired and received from NASA's other Goddard space centers, and then we've got some from Microsoft and then FGDC. So with that being said, here's our references, and thank you very much for listening to me.
Thank you, Isan. We have time for one quick question. There we go.
Thanks to everybody who's been talking in this session about communication. Asteroid Days, June the 30th was mentioned. I'm just wondering, let's imagine that we had an unexpected asteroid entry on Asteroid Day. How would the public respond to that?
So that's actually a very good question. This actually goes with the communication of the other folks that have been mentioned. Like the notification system will be really good to have, and also the education, the previous presenters spoke about. It's good to educate them and ahead of time, and then with our mitigation gateway, we can allow the researchers to figure some kind of system out, launch a spacecraft. But that's an amazing question. That's something that we'll have to, train our fellow public so that they can be prepared for that. Yep.
Thank you.
Thank you.